Assalamualaikum warahmatullahi wabarakatuh. We are from Group 1. We will be presenting our infographic about wet sulfuric acid. Alright, sulfuric acid, H2SO4, is a highly corrosive and dense liquid that is widely used in industrial chemicals. Its molecular formula indicates that each molecule contains 2 hydrogen atoms, 1 sulfur atom, and 4 oxygen atoms. The molecular structure features sulfur atom as central atom that is bonded to 4 oxygen atoms, and 2 of these oxygen atoms are bonded to 2 hydrogen atoms. This makes sulfuric acid is a diprotic acid, which means it is able to donate its 2 hydrogen ions, means protons, in reactions. And this fact contributes to its acidic properties. Sulfuric acid's ability to react with many substances underpins its extensive use in manufacturing fertilizers, chemicals, petroleum refining, metal processing, and in batteries. Its production and application are crucial to various industrial processes due to its reactivity and versatility in terms of its applications and relation with zero waste concept that we will be discussing in our infographic.
So, the wet sulfuric acid process involves several stages, which is gas cooling, catalytic oxidation, condensation, and sulfuric acid recovery. This overall process efficiently converts sulfur-containing gas, such as hydrogen sulfide, sulfur dioxide, and other sulfur compounds into high purity sulfuric acid. So, these are the key steps in the wet sulfuric acid process. The first one is gas cooling and cleaning. In this process, the sulfur containing gas is cooled and cleaned to remove particles and other contaminants. This process is done typically by using scrubbers and filter to make sure the gas is suitable for further processing. Number two, catalytic oxidation. After the previous process, the clean gas is heated and passed over a catalyst to oxidize sulfur compounds into sulfur dioxide, and then it will oxidize to sulfur trioxide. This process is done by using a catalyst called vanadium pentoxide. Number three, oxidation of sulfuric acid. The sulfur trioxide in the produced in the last process is then cooled and causing it to condense and react with water vapor present in the gas stream, which then forms sulfuric acid. Number four, sulfuric acid recovery. The resulting sulfuric acid produced is collected in a condenser, which is in high concentration, making it suitable for various industrial applications because it is pure sulfuric acid. And the last step, heat recovery. Overall, this process, which is wet sulfuric acid process, it generates a large amount of heat, which the heat used can be recycled and used back to produce electricity, which overall enhance the energy efficiency of energy used in this process.
The wet sulfuric acid process involves using sulfur or sulfur dioxide, which is a byproduct from other industrial process. For example, we have in the process of crude oil refining, hydrogen sulfide and sulfur dioxide is produced, and the byproduct is used in wet sulfuric acid process. Also, the gasification of coal also produces sulfur compound byproduct that is treated and used in WSA process. This wet sulfuric acid process also produces minimal amount of waste byproduct throughout the process. 98 to 99% of sulfur is used and produced. The WSA process can achieve a sulfur recovery efficiency of up to 99%, making it highly effective in capturing sulfur from industrial emissions. The wet sulfuric acid process does not produce solid or liquid waste, as the sulfur dioxide is completely converted into sulfuric acid. Hence, it leads to zero waste production of sulfuric acid in wet sulfuric acid process. It is also an economic way to get rid of sulfurous waste gases, which is byproduct from other industries. At the same time, the wet sulfuric acid process significantly reduces the emission of SO2, a major contributor to acid rain and air pollution. This is important in order to keep the environment safe.
While the WSA process is good for zero waste production, but it also has some weaknesses and problems that need to be addressed. The first problem is energy consumption. WSA process involves several energy-intensive steps, especially in gas heating stage. Therefore, the catalytic oxidation of sulfur dioxide to sulfuric acid requires significant energy to maintain the high temperature for the chemical reaction to occur. The second problem is corrosion issues. The process involves highly corrosive sulfuric acid and sulfur dioxide. This means that any equipment that comes into contact with the acid is at risk of severe damage. Therefore, this process requires materials of construction that can withstand the corrosive environments.
The third problem is high initial cost. WSA process face high initial cost due to complex reactants, advanced heat exchange and site-specific infrastructure, high temperature and corrosion resistance, maintenance and catalyst bed. In the nutshell, the high initial investment required for WSA technology, driven by specialized equipment, site-specific infrastructure, and regulatory compliance, can be a significant barrier. Companies must carefully evaluate this cost against potential long-term benefit to determine the economic viability of adopting the WSA process.
For the solutions of the problem is first by reducing energy consumption by implementing heat recovery systems to capture and reuse heat generated during the process. Second is minimizing corrosion issue by choosing material that are corrosion resistant material such as hastelloy steels to construct equipment, and by applying protective coatings to surfaces that are exposed to sulfuric acid. And lastly is lowering capital costs by using of standard materials for construction without the risk of corrosion. Since the process is operated above the acid dew point from incineration all the way to the condenser, the hardware can be constructed out of standard materials, lowering the capital cost without the risk of corrosion within the system.
The verses of Quran related to our topic is from Surah Al-Isra, verse 27. Bismillahirrahmanirrahim. Innal mubazzirina kanu ikhwana syayatini wa kana syaitanu lirabbihi kafura. The meaning is, indeed, the wasteful are brothers of the devil, and ever has Satan been to his Lord ungrateful. In the Islamic perspective, Islam emphasizes the efficient and responsible use of resources and minimizing waste. Therefore, optimizing the sulfuric acid production process to use less energy and produce fewer emissions align with this value.